Today we're going to be solving problem 14.4 from Math Methods by Riley. We want to find the values of alpha and beta that make this equation an exact differential. So I'm going to start by copying df of x and y below. So we know that this term is a of xy because it's associated with the dx. We know that this term is then b of xy because it's associated with dy. So the condition for an exact differential is the partial of a with respect to y equals the partial of b with respect to x. So we're going to do those derivatives, and then we can choose values of alpha and beta that make sense, that make the equation exact. So this first derivative goes away. This one is 0. And that derivative is just y to the beta power. So now we have this equation, and we want to pick values of alpha and beta such that this equation is equal. So we can choose alpha as -1 and beta as -2, and then we end up getting y to the -2 equals y to the -2. So these values of alpha and beta will make the equation exact. Now we want to solve df of xy equals 0. And to do this, we use what is on page 472 of the textbook, which says that the solution has this form. Now we'll just plug in our a and b, alpha and beta. Alpha was -1 and beta is -2. Remember, that's A and this is B. Now we want to integrate. I'm going to do these separately. F of y is a function that we can find later. So this integral has the form 1 divided by x squared plus a squared, which we know that's 1 divided by a arctangent of x divided by a. So by looking at this equation, we know that a is equal to the square root of 2 because a squared is 2. So that integral is just 1 divided by the square root of 2 times the arctangent of x divided by square root of 2. And then the other integral is just x divided by y plus f of y. Now our goal is to find the function f of y. And to do that, we want to take the derivative of f of xy with respect to y, and then equate it to our b of xy. So we're going to have 1 divided by the square root of 2 arctan keep your f of y, and set this equal to our b. Now this first term goes to 0, and we're going to have partial with respect to y equals x to the minus 2, x times y to the minus 2 plus 1. So we're going to have x y to the minus 2 plus df of y dy. These two terms cancel, and we end up getting that f of y, after integrating, is y plus c. Now on page 472, it also says that the function u of xy, which in this case is just our f of xy, is c, where c is a constant. So when we plug in, we'll just have c on one side. But this c that we got from f of y, when you subtract, it's just grouped into that c. So we're going to neglect this. And this is our answer. That's it.